Hey guys, welcome to this SPSS tutorial on the t-test. The first test I'm going to show you is an independent t-test. This tests the differences between two means, and specifically means belonging to two different groups of people. So this is often used in experiments where you have an experimental group and a control group. Now think back to the lecture where we had the driving example. This is what the data could look like. So here we have a group with people who were put in a driving simulator and told to drive a certain track. Then something unexpected happened while driving and they were forced to brake. This is their brake time in seconds. And then we had a group of another 40 people. They were told to do the exact same thing, but while calling hands-free. And this is their brake time. Okay, now we can analyze whether there are differences between the mean brake time of those two groups would go for everyone in our population if they were put for this experiment, or whether it's just a coincidence that we found this difference. Okay, in order to do this, go to Analyze, Compare Means, and then Independent Samples t-test. What you see here are two boxes. The first box is called Test Variables. Okay, here you put the dependent variable, so the variable brake time in our example. So we put that one in. Here the grouping variable. This is the two different groups you had. So we had a group not making a call and a group making a call. We put this one in. Then you have to define groups. Here you tell SPSS how you coded the groups. In this case, 1 was the control group and 2 was the experimental group. Of course, I could also have given them the label 0 and 1 or 12 and 3, as long as they're different numbers, it's fine. But you have to tell SPSS which numbers you used. Okay, so click Continue. Well, click OK. Then you get this output. You see the box we also discussed in the lecture. Here the means, so the mean brake time in seconds. What we see here is that the control group, so the people not making a call, had about half a second, and well, the hands-free calling, we see that they responded much slower. Actually, almost 1 second took them to respond to brake. So that's quite an indication that there is a difference. However, we don't know whether we can say that this might be true for all drivers. We have to do a test first. Like I said in the lecture, this whole row you can ignore. This is the row you'll be looking at, and specifically these figures. So what we have here is the mean difference. Well, we already saw. It's about 4 seconds, 0.4 seconds I should say, difference. And here is the p-value. Now, the p-value, as I explained, is the chance that you would find a difference of 0.4 seconds, an influence, what you might say, on hands-free calling, on the time it takes you to respond when something unexpected happens, of 0.4 seconds, if in reality you were wrong. So if in reality hands-free calling doesn't make a difference, then we would expect this to be 0. So if all people participated in our experiment, we would, under the null hypothesis, expect a 0 here. Of course, we only tested 80 people, so we found this difference. Now, this value indicates the chance that you would find this difference if the real difference between those two groups was 0. You can see that this chance is really, really low. What I said in the lecture, below 5% means you're right. This is way below 5%. 5% would say 0.05. This is 0.000, I don't know, some very, very very low number. So what this means is that the chance that we would find this difference of 0.4 seconds if hands-free calling didn't have any influence in reality, so if every driver ever would participate in our experiment, that chance is really, really tiny. So, quite informative. Okay. I'll show you the next flavor of the t-test. This is a test you can use when you didn't have two different groups, but you're testing for the difference between means of one group of persons. So you can imagine that this happens quite often in medicine experiments. Now, the example I cooked up here is, let's say that we have a group of chronic hiccup patients. Very nasty, but we have a promising medicine. Now, what we don't want is that we give some patients a placebo and some patients the real drug. No, we want to give all patients this drug, but we want to test whether it works. So what we do is we count the number of hiccups they have in 10 minutes before they get the treatment and after they get the treatment. Okay, so this is pre-treatment hiccups, the number of hiccups they have in 10 minutes. This is post-treatment hiccups. Now, what we want to know is whether the differences we find between those two moments, this is still about the same group of people, whether this difference would go perhaps for all chronic hiccup patients, not just the 40 that participated in our experiment. Okay, the way to test this, so the principle here, is exactly the same as with an independent t-test, only the flavor is different. Now, how to perform this test? Go to Analyze, Compare Means, and then Paired Samples t-test. You'll get a slightly different box. Here it says Paired Variables, and here you have to indicate the different variables you want to compare. So, we want to do the pre-treatment hiccups, number of pre-treatment hiccups, and post-treatment hiccups. Okay. Now, you can just click OK. There's no grouping variable, of course, because it was the same group of patients. They all got the treatment. There was just a pre-treatment measurement and a post-treatment measurement. So click OK. Now you get this box, the different means. What we see here is that the mean of the pre-treatment hiccups, so the mean number of hiccups, is around 4. The same is for the post-treatment hiccups. So the average amount of hiccups observed in 10 minutes was around 3.9 hiccups before they got the medicine and 4.17 after they got the medicine. Okay, here's the number of participants, 40. And here is the results. Notice that this table looks quite a lot like the table we've seen with the independent samples t-test. So you have the mean difference in number of hiccups, really small, not even one hiccup, actually 0.2 hiccups. The t-value, also very low, and the significance. Now, this significance is 0.65. What this tells you, actually, is that if you're wrong, so if the medicine doesn't work, the chance that you would find this difference, so a difference of 0.2 hiccups, among your population or with your experiment, is actually 65%. So that's quite a big chance. Remember that in the lecture I told you that this difference should be lower than 5%. 65% is of course way above this. So when there's a 65% chance that I would find this data, if I'm wrong, the medicine doesn't work, then I don't reject the null hypothesis, and actually I can't say whether it works or not. The only thing I can say is apparently, well, this time it didn't work. So it's not safe for me to say that this medicine works. There's actually a really high chance that I would find this if this medicine didn't work. Okay, that's it for the t-test. Good luck performing them.